This is a NEET 2016 question in mechanical properties of fluids. The problem is like this. Two non-mixing liquids of densities n rho and rho, where n is greater than 1. So what's the first thing that we can understand is density 1 is given like rho, density 2 is n rho, where n is greater than 1. It implies density 2 is denser than density 1. That implies n rho will be at the bottom of the container because it is denser, and rho will be at the top. That's the first thing that we need to understand. Then the height of each of the liquid is equal to h, of course. A solid container, next question is like this, next part is like this. A solid container of length L and density D is put in this container. Cylinder floats with its axis vertical and length rho L less than where PL, where P is less than 1, is in the denser liquid. So if I have to draw the diagram, let me draw the diagram and tell you what he is telling you is there is a big container who has two liquids of each of height h. This is liquid 1, upper one is liquid 2. I will just differentiate that with the colors. This is liquid 1, just for the sake of clarity. Who is the bottom liquid? As I told you, whose density is n times of rho. And upper one is another liquid, different color I am using just for the sake of understanding. That's little less denser, whose density is rho, because he said n is greater than 1. Now in this, a solid cylinder is placed. Let's imagine a solid cylinder. It's a solid cylinder placed in such a way that axis vertical, rho L is in the denser liquid while rho is less than 1. Out of the total length L, rho L is less than 1 means less part is in the liquid, right? So part of the liquid, sorry, not rho L, PL. Part of the liquid, I'll use a different color. PL is in the denser liquid. So this part of the length is PL. Automatically, what will be the other part? As the total length of the cylinder is L, as PL is in the denser liquid, L minus PL is in the rarer liquid, in lighter liquid at the top. That's what he's saying. Then what is the density D of that liquid? Density of that cylinder is that's what his question is. So the first thing that what we can understand is, on this what we can understand is, on this cylinder who is floating, the forces must be balanced. What are the forces? Weight of the cylinder is acting in the downward direction. These two liquids applies upthrust. Upthrust always acts in upward direction. So these two upthrusts are actually balancing its weight. So weight is acting downward. Upthrust of this liquid as well as this liquid are acting in upward, and both of them are balanced with each other, right? So what's the formulas I can write? How can I equate that, right? Weight equal to mass of the liquid. I'll write here. The weight of cylinder is mg, where m is the mass of the cylinder. Mass can be written volume into density of the cylinder into G. Volume can be written like area into length of the cylinder into density of the cylinder into G. Let me imagine area is A, length of the cylinder is given for you as L, density of the cylinder is D, that I have to find out into G. So weight means I can write area LdG, where A is the area of that cylinder. Then I have to write upthrust. What is upthrust is? Let's try to understand what do you mean by upthrust is. Yeah. Upthrust is the upward force acting on the solid when it is immersed in a liquid, that is equal to upthrust is volume of the fluid displaced, density of the fluid into acceleration due to gravity. This is according to Archimedes principle. We have made this derivation. For this formula, you can see the derivation in the playlist of the mechanical properties of fluids. What is volume of the fluid is as that part as vessel or a part of the cylinder is completely immersed in liquid, volume of fluid displaced equal to the volume of that part of the body itself, that immersed part, because that immersed part has pushed the fluid away. What is the upthrust 1? Then I can write upthrust 1 as volume of the immersed part is area into area of cross section is same, length of the immersed part. And the upthrust 1 is due to the lower liquid I am writing. So length of the immersed part is PL multiplied by density of that part of the liquid. Lower part of the liquid is N rho and G as per the formula. That is upthrust 1. Now I can write upthrust 2 also. Area of the cylinder is same. Then length of the cylinder in the second liquid. As I told you, as PL is inside, remaining one in the other liquid is L minus PL multiplied by density of that upper part of the liquid, rho and G. Now I know weight and I know upthrust, so I can just equate them. Upthrust 1 is A PL N rho G. This value, be careful between P's and rho's. Plus upthrust 2 is this one, A L minus PL rho and G. So areas can be cancelled, G's can be cancelled. Let's see what is remaining then. L into density of the liquid is length of the cylinder, density of the liquid is PL N rho here, plus multiply this L into rho minus P rho L. Anyway, L is also there in every term, that can be cancelled. So what's the density remaining? N rho plus rho minus P rho. That's the answer for the problem. So I can take again rho common in all of them. Then rho of what is remaining? N plus 1 minus P. Yeah, I have missed one thing here. Yeah. See, I have written only N rho, but this P is there, that's not cancelled. So P also will come. So if I take rho common, here N and P is also there. So that's the answer, but that's also not in that format. In these two terms also P is taken common. So rho of, let's take P common in the first and last term. That becomes n minus 1. What's remaining one is plus 1. So rho of P of n minus 1 plus 1. See here, where is that kind of an option? Rho of P of n minus 1 plus 1. That's the answer for the problem. So it's not a complicated problem, but you need to understand basics well and you shall apply the data without confusion. Then only you will get to the answer. I suggest you to go through the data and the way of that I have substituted the formula once again, get it. And if you have anything like a doubt, you can just make a comment in the video. Thank you for watching.